So in this episode of m squared m cubed or 2, Mrs. M's Math to the Masses, we're going to go over circle terminology. You need to have open the notes page for today, and we're going to go through each of those terms, and you'll need to understand these as we move through the unit's math. First term is going to be familiar and review. Several of them will. So the set of all points equidistant from the center. We're looking here, that's the term circle. Every point on this edge is the exact same distance from this center. So the first term on your sheet is circle. And the way you name a circle is you draw a circle, put a dot in the center. I'll give you an example. Because this circle has a C at its center point, we would call it circle C. You always use the symbol with the capital letter from the center of the circle. The next thing I want you to look for in this picture is a segment which passes through the circle center and has endpoints on the circle. Point D is on the circle, point A is on the circle, and this green line passing between them goes right through center C. That's the diameter. Again, review terminology. But the diameter of a circle has endpoints on the circle but must pass through the center. You'll learn it has a different name later in the notes. But diameter is always the best and most specific name. Now let's find the endpoints. It's going to be a segment where the endpoints are the circle's center and a point on the circle. So here's the circle center. You could be talking about point B, this segment here in blue. Point A, there's another segment in blue. Or this segment here stretching from C to D. It has to be a segment that the endpoint is, one endpoint is the center of the circle and the other is on the circle. CD, CB, and CA, each of those segments are called a radius, or all three, the plural is, all three are called radii. The next term is probably new. It's also a segment. The endpoints are on the circle. Look for something in orange, like this segment here, stretching from point A to point B. This is a segment whose endpoints lie on a circle, and it's called a chord, C-H-O-R-D, chord AB. You would draw it like we did line segment back at the very beginning of the year. You draw right the uppercase A, the uppercase B, and put a segment above them, a segment bar. Next, I want you to look for the line that stretches through AB. It goes completely through the circle and keeps going. So the line which intersects the circle at 2 points is called a secant, S-E-C-A-N-T. So to review how we draw segments and lines, this right here for this example would be chord AB because it starts and stops on the circle. But this to the right would be secant AB because it extends through the circle, goes to the same 2 points. Chord and secant. Now I want you to look at a line. It's in the same plane as a circle and it intersects at exactly 1 point. It will be perpendicular to the radius that extends to that point. So right now I want you to look at line T, lowercase t, right here, which intersects at exactly 1 point. This magenta colored line is called a tangent, T-A-N-G-E-N-T. So line T is a tangent line to circle C. The point where the tangent line and a circle intersect is the point of tangency. So just be point T. Now we're going to start looking on the edge of the circle because an unbroken part of the circumference is called an arc, A-R-C. This arc here from A to B is a minor arc because it is less than 180 degrees. And you would name it with the 2 capital letters and a curve above them to show we're talking about this piece of the circle, unbroken part of the circumference. Minor arcs are less than 180 degrees. Now look at this orange unbroken part of the circumference. It's a major arc because it's greater than 180 degrees, but less than 360. You name major arcs with 3 of the points on the edge of the circle. So you could do ATB, ADB, BDA, BTA. S is not on the circle, we cannot use it. And this lowercase t names a line, we cannot use it. But you always use 3 letters, and you have to include the first and last in the name. So use your arc symbol, and the 4 appropriate names for that orange arc would be ATB, ADB, BDA, or BTA. The unique arc with endpoints on the diameter, like this lime green color stretching from A to D, is a semicircle because it's exactly 180 degrees. Let's talk about angles for a minute. I want you to find an angle whose vertex is at the center of the circle. So go to C. Do you see this blue angle with the theta showing degrees? That is a central angle because its vertex is at the center of the circle. It is always the exact same amount of degrees as the arc it intercepts on the circle. They will be congruent. Theta degrees here for the angle is equal to the degrees of that arc of the circle. Another kind of angle you need to be familiar with is one formed by 2 chords with the vertex on the circle. So look for an orange angle down here at T. This chord AT intersecting with this chord here has left an amount of degrees there. This is called an inscribed angle because it's inside the circle. And the amount of degrees here at theta is 1/2 the degrees of the arc it intercepts. Now you see this radius marked here with a congruent mark. When you get to your key, there's going to be another circle over to the right-hand side with radii marked on it. And there's a term on your sheet that says if radii are congruent, and it means with circles. If you have 2 different circles with congruent radii, then the circles are always congruent. I want to talk about another term that would be like if you're holding a piece of pie or a piece of pizza. The crust at the top, think about that little area and look at this picture here. Bounded by this arc and this chord, look at this bright blue shaded area. That would have square units when you do the math, and it's called the segment of the circle. S-E-G-M-E-N-T. Obviously, totally different than a line segment like AB, which is a chord. The segment of a circle is this whole piece. Here's a little picture of it. And it's measured with area or squared units. Another term you want to look at is the part of a circle bounded by 2 radii. So you've got CB and AC, and you've got this whole piece of the circle that looks like a piece of pie or a piece of pizza. That's called a sector, S-E-C-T-O-R, circle sector. And the last term on your sheet that you need to be familiar with in terms of what you're filling in is a verb used often in the unit. It means to be opposite something. So if I pull open these notes a little bit further, let's see if you can see a right angle. Of a right triangle. This right angle subtends the hypotenuse, or the hypotenuse subtends the right angle. Subtend, S-U-B-T-E-N-D, means to be opposite. One other term I'd like you to see is concentric, because here's a radius to the pink circle, a different radii to the larger circle. These 2 circles have the same center, but they are different sizes, but they're called concentric circles because they share the same center. They would be similar, which means they're proportional from a different unit. And over here, if you remember, when we did trigonometry, we had to change our calculator from radians to degrees. To understand what a radian is, if you were to take the length of a radius and lay it on the curve of a circle, that is a radian. It's a curved length. So here you can see this radius, and this actually is supposed to be the same length, but it's curved. Think about your formula for circumference. Circumference is 2 pi radius. And that's because it would take that many radians to go around the edge of the circle.